This video, this video lecture, topic of this video lecture is Centroid. In engineering mechanics, there is one chapter, center of gravity and centroid. Centroid is defined for plane figure. In mathematics and physics, centroid is defined as the arithmetic mean position of all the points of the plane figure. Arithmetic mean position of all the points of the plane figure. If a cutout is made, suppose there is lamina. Lamina means thickness is negligibly small as compared to other two dimensions. So, if you find out the centroid and at the tip of a pin, if you place that lamina, place the centroid of the lamina, then it will be completely balanced. That point is centroid. At the tip of a pin, if you put the centroid of the lamina will be completely balanced. That point is centroid. Or mathematically it is defined as the arithmetic mean position of all the points of the plane figure. Mathematical expression you know. Since it is two-dimensional, so only x and y axis will be required. Coordinate of the centroid is denoted by x bar, comma y bar, or x suffix c, comma y suffix c. C for centroid. xc, yc. Okay. xc is equal to what? It is integration of x dA divided by integration of dA. dA is what? dA is d capital A. Okay. dA is elemental area. Means infinitesimally small area. That is dA. And what is x? Integration of x dA is there. What is x? X is the centroid of that elemental area. X coordinate. Right. Better to say x coordinate of the x coordinate of the centroid of the elemental area. And in the denominator appears integration of dA means total area of the plane figure. Similarly, yc is equal to integration of yc dA divided by integration of dA. So again in the denominator there is total area, and integration of yc dA means integration of y dA means dA is the elemental area and y is the y coordinate of the centroid of that elemental area. You have heard that if there is one axis about which the plane figure is symmetric, means on the axis if you put one mirror, then the mirror image and the other part of the plane figure will be same. That line or the axis is called axis of symmetry. If for a plane figure there is any axis of symmetry, then the centroid of that plane figure must lie on that axis. This can be proved mathematically. If there is any axis of symmetry of the plane figure, then the centroid must lie on that axis. Now you draw one plane figure and draw one line passes through the plane figure, passes through the figure, okay? And perpendicular to that line, you draw one more line, right? You give the names of those two axes, x-axis and y-axis. Now, suppose xc. Another axis which you have drawn, suppose name of that axis is x-axis. And the figure, the plane figure, is symmetric about the y-axis. Y-axis is the axis of symmetry. Now, x is what? X is equal to integration of x dA by integration of dA. So, integration of x dA means what? Suppose you divide the half of the plane figure, means one side of the plane figure. One side means what? One side of the axis of the plane figure, you divide the entire area into n numbers of small areas. Give the names like dA1, dA2, dA3 up to dAn, where n is actually infinity. And centroid of those x coordinate of centroid of those elemental areas are denoted by x1, x2, x3, x4 up to xn, like that. Then the numerator part, integration of x dA, that can be replaced by x1 dA1 plus x2 dA2 plus x3 dA3 plus similar procedure will be continued up to the last term xn dAn, right? You have taken only half part, one side of the axis, one side of the y-axis. So since y-axis is the axis of symmetry, so the other half also you can divide them into n small areas and similar areas, because the other half is just the mirror image. So those areas are also dA1, dA2 up to dAn, and coordinates will be what? In the first half, coordinates was x1, x2 up to xn, and since it lies opposite to the y-axis, then coordinates will be just with a negative sign, means minus x1, minus x2, minus x3 up to minus xn, right? Then in the numerator what appears? x1 dA1 plus x2 dA2 plus x3 dA3 up to xn dN, then minus x1 dA1 minus x2 dA2 up to minus xn dAn. So x1 dA1 minus x1 dA1 cancels each other, x2 dA2 minus x2 dA2 cancels each other. So all the terms are cancelled. So in the numerator, what is the result? In the numerator, 0 is there. You are getting 0 in the numerator. So 0 divided by total area, integration of dA is there. So 0 divided by total area becomes 0. So xc is 0. X is 0, what is the meaning? Centroid, x coordinate of the centroid of the total area, x coordinate of the centroid of the total area is 0. That means on that axis, means on the y axis, centroid lies. On the y axis, x coordinate is 0, you know this thing. Okay, so this way, this theorem can be proved. If there is any axis of symmetry, on that axis, centroid of the lamina must lie. If you find one more axis of symmetry, then on that axis also the centroid will lie. So what is the position of the centroid? The position of the centroid will be what? Intersection of the two axes. Okay, intersection of the two axes. Like if you take one rectangle, so you know that about the diagonal of the rectangle is symmetric. About the diagonal of the rectangle is symmetric. You know this thing. And you know that for any rectangle, two diagonals are there. And with respect to the both diagonals, the rectangle is symmetric. So, where will be the centroid? Intersection of the two diagonals. And this thing you have studied in your earlier classes. For square also same thing. For circle, through the center of the circle you draw x-axis and y-axis. Draw one circle first, and through the center of the circle draw x-axis and y-axis. So you know that with respect to x-axis circle is symmetric, with respect to y-axis circle is symmetric. That means centroid of the circle will be the point of intersection of the two axes. That means the center of the circle itself is the centroid. So, for any plane figure, if any axis of symmetry is known before calculation, then calculation is not necessary. Calculation can be overcome by using this axis of symmetry. Okay. For all the cases, you won't get that with respect to two axes, the plane figure is symmetric. Maybe only with respect to one axis, the plane figure is symmetric, and there is no other axis. So in that case, 50% of the calculation is not required. And you have to do the remaining 50% of the calculation. Okay. So in your exam, if such questions come, you have to clearly mention that this line is the axis of symmetry for the given figure, so centroid must lie on that line. So one coordinate is already known by using this logic. Okay. And then go for the calculation of other coordinate by using the formula of integration. Formula in the form of integration. Okay. I think this is sufficient for the explanation of centroid. And centroid is different from center of gravity. Center of gravity is the point of an object through which the total weight of the object acts. So in that case, weight is considered. And for playing figure, there is no involvement of weight. Okay. Okay. Thank you.